Hello everyone, this is Miss Mace. In this video we will solve past papers for Cambridge IGCSE Chemistry Syllabus 0620. We will do October-November 2025 paper 4 variant 2. Let's start. Question 1. The three states of matter are solid, liquid, and gas. Complete table 1.1 to describe the structures of solids, liquids, and gases in terms of particle separation, particle arrangement, and particle motion. Now, for the particle separation in the solid state, particles are touching. In the liquid state, also particles are touching, but in the gaseous state, particles are far apart from each other. Now, for particle arrangement, in the solid state, particles are arranged in a regular pattern, making a lattice, but in the liquid state, particles are randomly arranged. Particle motion. In the solid state, particles only vibrate in their position. In the liquid state, they move randomly past each other. In the gaseous state, also they move randomly in all directions. Next part. Substances can physically change. Name each physical change. Now, when we have solid that will change into liquid, this is called melting. When the liquid is changing into a gas, this is called boiling. It is possible also to call it evaporation. Going back from gas to liquid, this is called condensation. And going back from liquid to solid, this is called freezing. So, the change from solid to liquid, it is melting. The change from gas to liquid, this is condensation. From solid to aqueous, here we are talking about the dissolving of solute in a solvent, so it is dissolving. Next part. Gases diffuse. Describe in terms of particles why gases diffuse. Now, the particles in the gaseous state move all the time in all directions. That is the reason why gases can diffuse. Next, state what determines the relative rate of diffusion of gases at constant temperature. Now we know as the temperature increases, diffusion will occur faster, but at constant temperature, the factor that will determine the rate of diffusion will be the relative molecular mass. As the mass increases, the diffusion rate will decrease, and so the diffusion will happen slower. Next part. Gaseous oxides of nitrogen are atmospheric pollutants. One adverse effect of oxides of nitrogen is the formation of acid rain. State two other adverse effects of oxides of nitrogen. Those are the formation of photochemical smog and respiratory problems. Next part. In a catalytic converter, oxides of nitrogen are removed by reaction with toxic gaseous product of the incomplete combustion of hydrocarbon fuels. Two non-toxic gases are formed in this reaction. Now, name the toxic gaseous product of the incomplete combustion. Now, in combustion, it's possible to be complete or incomplete. If it is complete, the products are carbon dioxide and water. If it's incomplete, the products are carbon monoxide and water. So the toxic gaseous product is carbon monoxide. Name the two non-toxic gases formed in the catalytic converter. Now, in the catalytic converter, oxides of nitrogen reacts with carbon monoxide to produce nitrogen gas and carbon dioxide. So, nitrogen oxide will be reduced, carbon monoxide will be oxidized to make carbon dioxide and nitrogen. Next question. Iron is extracted from iron ore in a blast furnace. The iron compound in the main iron ore used in the blast furnace is iron 3 oxide. So here we are talking about Fe2O3. State the name of the main ore used in the blast furnace. The iron ore is hematite. State how the main source of heat is provided in the blast furnace. Now, in the blast furnace, first stage carbon from coke react with oxygen from air to form carbon dioxide. This is combustion reaction, which is exothermic and releases heat in the blast furnace. So that's how the blast furnace is heated, by burning carbon from coke in air. Next. Name the gaseous reducing agent in the blast furnace. Now, the reducing agent in the blast furnace is carbon monoxide, which will form after carbon from coke reacting with carbon dioxide from the previous equation to give to carbon monoxide. Write a simple equation for the reduction of iron 3 oxide by the gaseous reducing agent. Now, iron 3 oxide is Fe2O3. It will react with carbon monoxide, which is CO, to give iron metal and carbon dioxide. Now, for balancing, notice that we have 2 iron on the reactant side, but it was only 1 iron, so we have to multiply iron on the product side by 2 to balance iron atoms. To do the balancing for oxygen, we multiply 3 carbon monoxide and 3 carbon dioxide. Note that we need 3 of carbon monoxide to reduce the iron oxide, which also contains 3 oxygens. Next part. The main impurity in iron ore is silicon 4 oxide, which is SiO2. Write 2 simple equations to show the role of limestone, which is calcium carbonate, in removing silicon oxide, which is mainly came from sand from iron ore. The first one, calcium carbonate will go through thermal decomposition to form calcium oxide and carbon dioxide. The formed calcium oxide will react with the silicon dioxide, making calcium silicate, which is common name is slag. So slag is the common name. Remember here, this reaction is also classified as a neutralization reaction because calcium oxide is basic, silicon dioxide is acidic, and the product here it is calcium silicate. So the type of reaction for the first one is thermal decomposition, but for the second is neutralization reaction. Next. Table 2.1 shows 4 different isotopes of iron, A, B, C, and D. Explain why A, B, C, and D are isotopes of iron. Now, for atoms to be isotopes, they should have the same number of protons, but different number of neutrons. So the 2 marks stands for the same number of protons. This is the first mark. Different number of neutrons. This is the second mark. So please mention both of them. Next. Iron can form 2 different ions, iron 2 positive and iron 3 positive. Complete table 2.2 to show the number of protons, neutrons, and electrons in the 2 iron ions shown. Here we have iron 2 positive and iron 3 positive. How can we tell the number of protons? Notice that the mass number, or what we call it a nuclear number, is given for both ions, but the atomic number is missing. How can I know the atomic number? I go to the periodic table. I notice the iron in the periodic table, which is located in the transition element area. Here is iron. The atomic number is 26. Back to the table and record it is 26 for both ions. Now, how can we tell number of neutrons? Number of neutrons, it's calculated from the mass number. We have 54 as mass number, and we know that the mass number represents both protons and neutrons. So we will say 54 equals 26 plus the number of neutrons. So number of neutrons will equals 54 minus 26, and that's equals to 28 neutrons. We will do the same for the other ion. We will say 58 minus 26, that is equal to 32 neutrons. Now, for the number of electrons, originally we know for a neutral atom, number of protons equals number of electrons. So it should have 26 electrons, but because it is positive 2 charge, that means it lost 2 electrons. So we will say 26 electrons minus 2 electrons, that equals to 24 electrons for the first ion. For the second ion, we have 26 electrons originally. 3 electrons are lost because the charge, it is 3 positive, so the atom lost the 3 electrons. So the total electrons now equals 23 electrons. Next part. Describe a test for aqueous iron 2 positive ions. Now, to test for cation, we can use solution of sodium hydroxide, and the observation for iron 2 positive, it is a green precipitate that is insoluble in excess. Please note not to mix it with the observation for iron 3 positive. The iron 2 positive gives a green precipitate, while the iron 3 positive gives a brown precipitate. Now, next part. An oxidizing agent converts iron 2 positive ions to iron 3 positive ions. Define the term oxidizing agent. Oxidizing agent is a substance that is reduced while oxidizing another reactant. So the oxidizing agent in a redox reaction, it is the one that is responsible for oxidizing the other reactant, but itself it will be reduced. So the first mark to say that it is the substance which will reduce, and the second mark stands for saying that it will oxidize the other reactant. Explain why the conversion of iron 2 positive ions to iron 3 positive ions is described as oxidation. Now we know that oxidation is defined as gain of oxygen or loss of electrons or increase in the oxidation number. Here we can note that the oxidation number increased from 2 positive to 3 positive. Also, we can say that iron 2 positive lost 1 electron to change the charge from 2 positive to 3 positive. Next part. The oxidizing agent for the conversion of iron positive 2 ions to iron 3 positive ions is aqueous potassium manganate 7, which is KMnO4. State one condition needed for the oxidation to take place. The essential condition for this reaction is acidic condition, so we should add acid. Next, iodide ions I negative reduce iron 3 positive ions to iron 2 positive ions in aqueous solution. Okay, suggest the identity of the other product. So we are talking about the other product formed in this reaction. Now, when iodide ions reduce iron ions, they will be oxidized. Oxidized, that means they will lose electrons. So I minus will change into iodine atom by losing 1 electron. We know that iodine found in nature as diatomic element, so it would be I2. So we will need 2 iodide ion, which will lose 2 electrons, 1 from each. So what is the substance that will form? It is iodine molecule. Next question. A student prepares a sample of insoluble barium sulfate, BaSO4. The student adds aqueous sodium sulfate, Na2SO4, to aqueous barium chloride, BaCl2. The student carries out the following steps. Step 1. Dissolve 0.1 moles of barium chloride in 100 centimeter cube of distilled water in a beaker to form barium chloride solution. Step 2. Add an aqueous solution which contains 0.1 moles of sodium sulfate to the beaker containing the barium chloride solution from step 1. Step 3. Stir the mixture and then filter it. Step 4. Dry the solid left in the filter paper. Complete the symbol equation for the reaction. Include state symbols. First of all, we can notice barium chloride reacts with sodium sulfate. The first product is barium sulfate. So the barium positive ions combine with the with the sulfate negative ions, and they will form barium sulfate. Then the sodium ions will combine with the chloride ions to form NaCl. So the other product is sodium chloride. Now for balancing, notice here we have 2 sodiums and 2 chlorines. On the product side, only 1 sodium, 1 chlorine, so we have to multiply it by 2. For state symbols, barium sulfate is solid because it is insoluble salt, as it is mentioned in the question. For sodium chloride, it is aqueous because sodium compounds all are soluble in water. Next one. Calculate the mass of solid barium chloride dissolved in step 1. Here is step 1. 0.1 moles of barium chloride dissolved in 100 centimeter cube of water. How can we calculate the mass? We use the rule moles equals mass over molar mass. So we can rearrange it. Mass equals mole times mR. We have the moles, but we don't have the mR. So what should we do? We go to the periodic table, look for the relative atomic masses for barium, as we see it here, which is 137, and for chlorine, which is 35.5, and here they are. So 137 for barium, 35.5 for chlorine. Go back and do the calculations. You will find that the molar mass for barium chloride, it is 208. So by calculation, we find the mass equals 20.8 gram. Next. The concentration of sodium sulfate in step 2 is 1.25 mole per decimeter cube. Calculate the volume in centimeter cube of 1.25 mole per decimeter cube sodium sulfate added in step 2, which contains 0.1 moles of sodium sulfate. Now, what should we do? We have to use the rule which states concentration equals mole over volume. Number of moles are given. Volume, we have to calculate it, and concentration it's given. So we rearrange the rule. Volume equals moles over concentration. Substitute number of moles over the concentration, and that would equal to 0.08 decimeter cube. But the question is asking for the volume in centimeter cube. So we have to multiply it by 1000, and so the total volume equals 80 centimeter cube. Next one. State the color of solid formed in step 2. Now the solid formed in step 2 is barium sulfate. The color of barium sulfate is white solid. The mixture is filtered in step 3. State the general term given to a solid left in the filter paper after filtration. Now when we do filtration, we need a funnel holding a filter paper, we need a flask to hold the filtrate. Now the solid which will be trapped on the filter paper, this is called residue, and the liquid that will pass through the funnel, it is called filtrate. So the solid, it's called residue. Then the actual mass of dry barium sulfate collected in step 4 is greater than the expected mass. This is because the student should do an additional step between step 3 and step 4. Suggest what the student should do in this additional step and explain why the actual mass collected is greater than the expected mass. Now in step 3, the student stir the mixture and then filter it directly. He dry it. Now he should wash it with distilled water to remove any contamination of the sodium chloride to prevent it affecting the mass. So he should do rinsing the residue with water, and the explanation: the mass was greater because the dry residue contains solid sodium chloride, which should be removed through the washing with distilled water. Next one. State the name of this method of salt preparation. Now when we are going to prepare an insoluble salt, this method is called precipitation. Next, state the name of a different barium salt that can be used instead of barium chloride, sulfate salt that can be used in place of sodium sulfate, barium salt that can be made by this method. This method uses two soluble salts to dissolve them, mixing them, and then make an insoluble salt. So we have to choose a soluble salt for barium sulfate other than barium chloride, so we can use barium nitrate. Remember that all nitrates are soluble salts. Now, sulfate salt, we can suggest to use potassium sulfate or ammonium sulfate because both are soluble in water. Now, for barium salt, we can suggest barium carbonate because we know that carbonates all are insoluble except for a group 1 and ammonium carbonate. That is for this question. Let's go to the next one. Question 4. Nitric acid HNO3, sulfuric acid H2SO4 are strong acids. Ethanoic acid CH3COOH is a weak acid. 1 mole of each acid is added separately to 1,000 centimeter cube of distilled water to form dilute solution. All 3 acids dissociate in distilled water. State the formula of the common cation produced when each of the 3 acids dissociates in water. Now, cation, we are talking about the positive ion. The positive ion all acids produce is hydrogen positive 1 ion. Explain in terms of dissociation why nitric acid is described as a strong acid and ethanoic acid is described as a weak acid. Now, to describe as acid to be strong acid, that means it will undergo complete dissociation, but to be a weak acid, it will undergo partial dissociation. So not all the molecules of the acid will break down into ions. Next. State which of the 3 dilute acids will have highest pH value. Now the pH scale starts from 0 to 14 and we have 7 in the middle. The 14 represents the basic and the 0 represents the strongest acid. So as the value of the pH decreases here, we are talking about a stronger acid. As the value of the pH increases from 0 to 7, we are talking about a weaker acid. So the one with the highest pH value would be the weakest acid, and here it would be ethanoic acid. Next. State the color of thymolphthalein in all 3 dilute acids. Now, thymolphthalein is blue in basic solution, but colorless in acidic solution. So here they are acids and the color would be colorless. Give the formula of the anion formed when sulfuric acid dissociates in water and when ethanoic acid dissociates in water. When sulfuric acid breaks down into ions when dissolved in water, it will give 2 hydrogen ions and 1 sulfate -2 ion. So it is SO4 -2. Remember, anion, I'm talking about the negative ion. So it is SO4 negative. For ethanoic acid, we have CH3COOH. It will break down to give hydrogen positive 1 ion and ethanoate CH3COO negative ion. Name the 2 gaseous products formed during the electrolysis of dilute sulfuric acid. When I'm talking about solution of sulfuric acid, the ions present in the solution are hydrogen ions and hydroxide from water, hydrogen ions and sulfate ions from the sulfuric acid. So the product on the cation would be hydrogen gas and on the anode would be oxygen gas. Name the salt formed when calcium metal reacts with ethanoic acid. Now, metal acid typical reaction, the products are salt and hydrogen gas. The name of the salt would be calcium ethanoate. Next one. Aluminum nitrate AlNO3/3 is made when dilute nitric acid reacts with aluminum hydroxide, which is AlOH/3. Aluminum hydroxide acts as a base in this reaction. Define the term base. Base is defined as a proton acceptor. AlOH/3 or aluminum hydroxide is not an alkali. Suggest what this tells you about the solubility of aluminum hydroxide. What is the meaning of alkali? Alkali is soluble base. So because it is not an alkali, so that means aluminum hydroxide is insoluble in water. Name one other compound which forms aluminum nitrate when added to dilute nitric acid. So we need another reactant other than aluminum hydroxide that can react with nitric acid to give aluminum nitrate. We can suggest aluminum oxide, which is another base which is possible to react with the nitric acid to give aluminum nitrate as a product. Next one. The oxidation number of oxygen atoms in aluminum nitrate is -2. The formula of aluminum ion in aluminum nitrate is Al3 positive. Determine the oxidation number of nitrogen atoms in aluminum nitrate. What should I do? I have to notice that the overall charge here, it is 0. There is no charge. It's a neutral salt. Now the charge for aluminum, it is a 3 positive. For nitrogen, we don't know it, but how many nitrogen do we have? We have 3. So we will say 3x plus how many oxygens? 3 times 3. So we are talking about 9 times 2 negative, as it's mentioned in the question. So totally equals 0 charge. Do the calculations. We will say 3 plus 3x minus 18 equals 0. So 3x minus 15 equals 0. 3x would equal positive 15, and so x equals positive 5. So the oxidation number of nitrogen is positive 5. Next question. This question is about homologous series of alkanes. 3 general characteristics of alkanes are: they are generally unreactive because they do not have a functional group. They show trends in their physical properties such as melting points and boiling points. They have similar chemical properties. Describe 2 other general characteristics of the homologous series of alkanes. The other 2 are, they all have the same general formula, which is CnH2n plus 2, and the successive members in the series differ by CH2 unit. Next one. State the trend in the boiling point of the alkanes as the carbon chain length increases. As the molecule becomes bigger and the hydrocarbon chain length increases, the melting and boiling points increases. So the trend here for boiling points increases as the carbon chain length increases. Name one other physical property of alkanes that shows a trend other than melting and boiling points. Describe this trend as the carbon chain length of alkanes increases. We can suggest viscosity, and viscosity increases as the carbon chain length increases. State why alkanes are described as saturated. Now here we are talking about saturation in terms of organic compounds, not about saturated solution. Please don't do this mistake. So note here the saturated compounds on alkane, or generally in organic compounds, we are talking about compounds that contains all carbon-carbon bonds only as single covalent bonds. Next part. Propane has the structural formula CH3, CH2, CH3. When propane undergoes monosubstitution reaction with the chlorine at room temperature, 2 organic products can be formed. State one condition needed for the substitution reaction to take place. The essential condition is ultraviolet light, which is needed to provide the activation energy for the reaction. Give the structural formula and state the name of each organic product formed. Now we have propane, which has already 3 carbons, and we have remaining bonds with hydrogen. Now for substitution, one of the hydrogens will be substituted with the chlorine atom. So we have 2 options. The first one is to substitute hydrogen on the first carbon by chlorine. So here it is on the first carbon. So this one is called it's called 1-chloropropane. 1-chloropropane. So how can we write it as a structural formula? We write it as CH3, CH2, CH2, Cl, because here we have CH2 part, that is attached to one chlorine atom. The name is 1-chloropropane. The other option that is possible for the organic product is to have C2-3 carbons, but the chlorine atom to be attached on the second carbon. Other bonds also are carbon hydrogen. So the molecule here is called 2-chloropropane. Why it is 2-chloropropane? Because the chlorine atom is attached to the second carbon, not to the first carbon. So we represent it as the structural formula CH3CHCl. Note where we represent the Cl beside the second carbon and then CH3. The names are 1-chloropropane, and here it is 2-chloropropane. The two products formed are structural isomers of each other. Define the term structural isomers. What do I mean by structural isomers? Those are compounds with the same molecular formula but different structural formula. That is the meaning of isomers. Next question. Question 6. Compound E shown in figure 6.1 is an ester. On figure 6.1, draw a circle around all the atoms which make up the ester linkage. Now, the ester linkage is that part in the middle of the molecule which consists of carbon double bond O, single bond oxygen. This is what we call it, ester linkage. Now, name compound E. How can we name an ester? When naming an ester, you have to focus on this oxygen, which is bonded to the carbon with a covalent single bond. Then count how many carbons are attached to it in the hydrocarbon group. Here we have 2 carbons. So this part is called ethyl. The ethyl group came from ethanol. So alcohol which is needed here is ethanol. Now the other part which is connected from the side of the carbon double bond O, here it consists of 1, 2, 3 and 4 carbons, so it's called butanoate. This part came from the acid butanoic acid. So the name of this ester is ethyl butanoate. Deduce the empirical formula of compound E. How can I tell the empirical formula? We have to count the atoms for each element and find the molecular formula, then decide what would be the empirical, which is the simplest ratio. How many carbons you have? 1, 2, 3, 4, 5, 6 carbons. So we have C6. How many hydrogens we have? 3, 5, 7, 9, and 12 carbon hydrogens. How many oxygens we have? 2 oxygens. So the molecular formula here, it is C6H12O2. How can we simplify it? It would be simplified into C3H6O. So this would be the empirical formula. Next part. Now the next part, compound E is produced when 2 different compounds react together in the presence of a catalyst. Now we found out the name of the 2 compounds that react together to produce compound E in the previous part. Those are ethanol and butanoic acid. Suggest a suitable catalyst for this reaction. The suitable catalyst here, it would be acid, and specifically it is sulfuric acid. Determine the number of unbranched esters which have the molecular formula C5H10O2. How can I tell? I have to sketch the possible options for esters with the formula C5H10O2. The first option, start by drawing the functional group here, which is the ester linkage, C double bond O, and then on this oxygen attach 1 group containing 1 carbon and put the rest of the carbons on the other side. We start with 1 attached to the oxygen. Here we have the second, so the third carbon, 4th carbon, and 5th carbon. Other option is to put 2 carbons on the side attached to the oxygen as CH2 CH3, and so here only we will have 3 carbons with the side of C double bond O. So here we have ethyl propanate. Other option to attach 3 carbons to the oxygen side, CH2, CH2, CH3. So this is a propyl, and here we will have ethanoate. The last option is to attach 4 carbons to the side next to the oxygen, CH2, 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 CH3, which is a butyl part, and here we have methanoate. So maximum we can have 4 unbranched esters. So the answer here it would be 4. All unbranched esters with the molecular formula C5H10 combust completely to form carbon dioxide and water only. Write the simple equation for the complete combustion of C5H10O2. Now, when we have this fuel, we will talk about the combustion. Combustion needs oxygen as the other reactant. The products are carbon dioxide, CO2, and water, H2O. Now, for balancing, here we have 5 carbons. So absolutely, we have to multiply the carbon dioxide by 5. On the reactant side, we have 10 hydrogens. So on the product side only, we have 2. So we have to multiply it here again by 5. Now find out the total oxygens for balancing. On the product side, we have 10 oxygens from the carbon dioxide, 5 oxygens from water. So in total, we have 15 oxygen atom. How can we balance it on the reactant side? Notice we have 2 oxygens in the fuel and we have O2 molecule. What should I do? I will say 15 minus the number of oxygens in the fuel. Here they are 2, so there will remain 13 needed oxygen. How can I make 13 oxygen atom from the O2? I will use the fraction 13 over 2. 13 over 2 times 2. In total, it will give me 13 oxygen atom. Beside the 2 in the fuel, totally will add up to 15 oxygen atom. So the overall balancing should contains the fractions 1 for the fuel, 6.5 for oxygen, 5 carbon dioxide, and 5 water molecules. If you don't like to use the fractions, you can say 2 of the C5H10O2 will react with 13 O2 to produce 10 carbon dioxide and 10 H2O. All are accepted if the multiplications are correct and the ratio between the coefficients of balancing are correct. That was the last question for this paper. Thank you for listening and watching. If you have any comment or question, please don't hesitate to write it in comments. Bye bye.